So welcome to our topic, inverse of one-to-one correspondence. Let us first recall our previous topic with these following questions. Number one, which figure given below is symmetrical to each other? Is it letter A, letter B, letter C, or letter D? Of course, answer is letter D. Number two, the following are inverses of each other except one. Letter A, fraction and decimal. Letter B, addition and subtraction. Letter C, exponential and logarithm. Letter D, multiplication and division. Answer for number 2 is letter A, fraction and decimal. Number 3, the following are the ordered pairs of a function: 2, 5, 3, 6, 4, 7, 5, 8. Question, which could be the set of range of its inverse? Letter A, 5, 6, 7, and 8. Letter B, 2, 3, 4, 5. Letter C, 2, 5, 3, 6. Letter D, 4, 7, 5, 8. Answer, letter B. We have 2, 3, 4, 5. Number 4. The following are the ordered pairs of an inverse function: 3, 0, 2, 1, 1, 2, and 0, 3. Question, which could be the set of domain of the function? Letter A, 0, 1, 2, 3. Letter B, 3, 2, 1, 0. Letter C, 3, 0, 2, 1. And letter D, 1, 2, 0, 3. Answer, that is letter A, 0, 1, 2, and 3. Last question, which graph shows inverses of each other? Is it letter A, letter B, letter C, or letter D? Answer is letter C. So let f be a one-to-one function whose domain is the set of A and range be the set of B. Then the inverse of f, denoted by f to the power of -1, is a function with domain B and range A. Consider the function f of x is equal to x plus 2 and has the following ordered pairs: x with the values -3, -2, -1, 0, 1, 2, 3, 4, 5. For f of x with the following values: -1, 0, 1, 2, 3, 4, 5, 6, and 7. Interchanging the ordered pairs of the function, we get the ordered pair as this: x with the following values: -1, 0, 1, 2, 3, 4, 5, 6, and 7. And for f of x with the following values: -3, -2, -1, 0, 1, 2, 3, 4, and 5. As you notice that y is related to x by f of x is equal to x minus 2. Then the equation f of x is equal to x minus 2 is the inverse of the function f of x is equal to x plus 2 and can be properly written as the inverse of x, which is equal to x minus 2. For a given one-to-one function, there exists an inverse function. In finding the equation of its inverse, do the following steps. The first one is express the function in y is equal to f of x form. Second one, replace x with y variable and y with x variable. And the last one is solve y in terms of x variable. So let us have the first example. Find the inverse of the function f of x is equal to 2x plus 3. So the first step, we need to rewrite the function to the form y is equal to f of x. So we have y is equal to 2x plus 3. Second step, interchange the x and y variables. So from y is equal to 2x plus 3, we have x is equal to 2y plus 3. Third step, solve for y in terms of x. So we have x is equal to 2y plus 3. Evaluate, we have x minus 3 is equal to 2y. Evaluate further, we have our y is equal to x minus 3 over 2. Therefore, the function f of x is equal to 2x plus 3 as an inverse of x minus 3 over 2. Let us have example number 2. Find the inverse of the function f of x is equal to x plus 4 divided by 5. First step, rewrite the function in the form of y is equal to f of x. So we have from f of x is equal to x plus 4 over 5, it will become y is equal to x plus 4 over 5. Second step, interchange the x and y variables. So from y is equal to x plus 4 over 5, it will become x is equal to y plus 4 over 5. The third step, we need to solve y in terms of x. So we have x is equal to y plus 4 over 5. Evaluate. So we have 5x is equal to y plus 4. Therefore, our y is equal to 5x minus 4. You can write as this way or as this way. So therefore, the inverse of the given function, which is f of x equal to x plus 4 over 5, is 5x minus 4. If a function f is 1 to 1, then there exists an inverse function which can be written as f to the power of negative 1. Then we can conclude that first one, the function f has an inverse of f to the power of negative 1. Second, for all x in the domain of the inverse, function of the inverse is equal to x. Third one, for all x in the domain of the function, inverse of the function is equal to x. Let us remember the following. A function is 1 to 1 if its graph satisfies the horizontal line test. If a function f of x is 1 to 1, then there exists an inverse of the function, which can be written as f to the power of negative 1 of x. To show that f of x and f to the power of negative 1 of x are inverse functions, function of the inverse is equal to x must be true for all x in the domain of inverse, or the inverse of the function is equal to x must be true to all x in the domain of the function. The graphs of the function f of x and the inverse are symmetrical to the line y is equal to x. And that ends my presentation. Thank you.